Hello everybody, this starts our Day 3 notes in section 2.1. We have spent the last 2 days in class reviewing all of our knowledge, our 9th grade knowledge of calculating slope and parallel and perpendicular lines. Today starts our first day of notes in the real world. These next couple pages are actually meant to be for days 3 and 4, so we're going to move around a little bit. This warm-up is specifically for us today. And is a Batman question. So it says, Batman had 5 gallons of gasoline in his motorcycle. After driving 100 miles, he had 3 gallons of gasoline left. The graph below shows Batman's situation. So here is the start. He hasn't driven any miles, and as he's driving, the amount of gasoline decreases. So it does make sense that this is a decreasing line. Let's get into our questions. First it says, what are the coordinates of 2 points that you could use to find the slope of the line? Now we need to remember that technically we could actually choose any ordered pair we want because this line is made up of so many points graphed so close together you can't see the space in between them. But I do see here that I've got 3 points that have been kind of exaggerated a little bit here for me. This one is 0, 5. This one is 100, 3, and then finally 150, 2. And as we have reviewed the past couple of days, it does not matter which 2 ordered pairs you choose. So you could choose 2 and I could choose 2. We should still get the same answer. For the purpose of the notes, I intend to use 0, 5. And maybe this middle one, 100, 3. But again, feel free to use any 2 points, we should get the same answer. B says, what is the slope of the line? Write in fraction form and use the units of measure you find on the y and x axes. So let's get into calculating. I'm going to bring down my 2 ordered pairs, 0, 5 and 100, 3. My slope is going to be change in y divided by change in x. And we've seen this little triangle in our notes, but we haven't actually talked about it for real yet. So in math, this triangle means change, which is another way of saying difference. And is connected to subtracting. So for example, if you were in the store and something cost $3 and you handed the cashier a $5 bill, your change would be $2 because 5 minus 3 is 2. So think of it that way. But using that triangle is very helpful to be a shortcut. So we're saying, reminding ourselves, change in y divided by change in x. So change in y values, we are going to subtract 3 minus 5 divided by 100 minus 0. And we get negative 2 divided by 100, which simplifies to negative 1 divided by 50. Or you could have done 5 minus 3 divided by 0 minus 100. Because if I were to add my little x1, y1 labels here, x2, y2, this top example is y2 minus y1, and then this is x2 minus x1. But in class, we talked a lot about how there's 2 ways to calculate slope. You can start with y2, or down here shows starting with y1. Remember the rules are, if you start with y1 in the numerator, you have to start with x1 in the denominator. But notice we will get the same answer. 5 minus 3 is a positive 2, 0 minus 100, negative 100. This still equals negative 1 divided by 50. Now if we go and interpret, because notice it said, this is important, write in fraction form and use the units. That's talking about labels. So when I look at my graph, X is defined as miles driven, and Y is gas in the gas tank. So if I go back, change in Y, my Y values represent gallons of gas. And if I look change in X, well, X I know is miles. So that means that he used 1 gallon of gas every 50 miles. And if I look at my C question, it says write the slope as a unit rate. And that's going to be an important vocab word for us, unit rate, which means per 1 mile. But if I look, we actually already did that. So when we simplified our answer up here, we actually already took care of this question. Actually, scratch that. No, we didn't. Sorry. The reason we didn't was because right now we know 1 gallon per 50 miles. But unit rate is saying per 1 mile. So to figure that out, let's all get out our calculators. See, I have mine. Take out yours. Press pause if you need to go get it. And we are going to divide and get a decimal. So you let me know what decimal you get, write it down, and then we'll see if we match. Press pause until you have your own calculator, please. And when I divide, I got negative 0.2 gallons per mile. So now instead of per 50 miles, now I know per mile. So this means per 1 mile. And that's what unit rate is all about. Unit rate is all about per 1 of whatever you're talking about. The key to that, so then write a descriptive sentence explaining how you figured out the unit rate. You get the unit rate So you get the unit rate by dividing the slope. So here it was negative 1 divided by 50. We actually did that division and got negative 0.2 gallons per 1 mile. Okay, warm-up is complete. That was an awesome start to our real-world applications. Let's get right into our notes. So what we're going to do is actually skip this one, day 4 warm-up. So this is going to be tomorrow's warm-up, and get right into the notes. So come over here where you see Unit 2, Day 3 and 4. And I know that yours actually has a place for you to write some steps. I know mine doesn't show that. Yours does. Let me just get to the same page. So right now we are all on page 29. And at the top of yours, I'm just going to move this down. Oops. It says to find the average rate of change. So let's get those 4 steps. 1, 2. Step 1 is going to be define the variables. Step 2, identify 2 ordered pairs. 3, calculate M. And then last but not least, step 4, interpret meaning using XY labels. I'm going to make this stand out a little bit. So at the start of calculating the slope from now on, we're going to be putting that little triangle y divided by triangle x, meaning change in y divided by change in x, so that we remember what label goes where. And the best way to get good at these steps is to practice. So let's get right into number 1. Notice it says day 3 and 4 notes. This covers 2 days. So what I plan on doing is day 3 notes. If you want to make a note of this. It's going to be all of the odds. And day 4 notes will be all the evens. If you end up trying all of them on your own, that's awesome. Just make sure you use my video that I post tomorrow to help you check your answers. Getting right into number 1, find the average rate of change of the real-world situations presented below. Make sure to define your variable and write a sentence describing what your slope means. So those directions actually encompass 2 of our steps, right? Defining your variables and interpret the meaning. How awesome. Number 1, you are starting a new company selling, what would you sell? Let's say sneakers. In 2009, you had a profit of $173,000. In 2013, the profit was $197,000. Find the average rate of change. So before I do anything else, I'm going to go back up to the top and say, okay, what are my 4 steps? Step 1 says, define my variables. So let's do that first. X is going to equal, and Y is going to equal. Remember, no numbers when defining variables. That got some of us on the test. I see time is present, so I'm going to let X equal number of years, and my Y value is going to equal profit. So let's see, did I finish step 1? Yes, I did. I defined my variables. Next, we're going to identify 2 ordered pairs. And the key is realizing that that's going to look like X, which is year, comma, profit, Y. So year, comma, money. Let's see if we can find those ordered pairs. 2009, comma, 173,000. And then in 2013, 197,000. That's it. I've got my ordered pairs. Now that I've got my ordered pairs, calculate the slope. So let's go ahead and do that. I calculate the slope. I'm gonna let myself use this whole space right here. So I'm going to go all the way over to the left and say m equals change in y divided by change in x equals, let's see, my y values are right here. So that's going to be 197,000 minus 173,000, all divided by, subtracting my x values, 2013 minus 2009. I take out my calculator and I do 197,000 minus 173,000 So again, that was 197,000 minus 173,000, and we get 24,000. Divided by 2013 minus 2009. So again, 2013 minus 2009, and I get 4. Now technically this is a slope, but we want the unit rate. What I mean by that is if I actually went and looked for my labels right now, and sorry if it's kind of loud outside, they're cutting the grass right now, and I've tried pressing pause like 4 times, and he's still cutting the grass. I'm sure he's doing a great job, but I'm very sorry if it's interrupting the video. So that's the noise you hear right now. When I look at my Y values, that's money. So right now I know $24,000 per 4 years, but nobody's really interested in 4 years. People want to know per 1 year. So that's where what we wrote at the bottom of the warm-up is helpful to us. We can divide. So let's do 24,000 divided by 4. And that gets us 6,000. To know what that actually means, we go back. See how we've kept like this nice line going? So when I go back, again, I know that Y is money. So if that's dollars, and then if I look in the denominator, I go across X, X is years. That's it. So it's $6,000 per year. That's my average rate of change. And we have accomplished our first average rate of change real-world problem. Great. Let's do another one. We get good by practice. Let's go do number 3. Number 3 says, Maria took a trip on her bicycle. The table below shows the distance she traveled. Find the average speed in kilometers per hour. So what's nice about tables is that I see my X values is minutes and Y is distance right away. So off to the side, X equals number of minutes and Y equals the number of kilometers. That's how distance is being measured. Now, in terms of it mattering how many points I choose, let's see if this is counting by a constant value. To get from 0 to 20, I add 20. 20 plus 20 is 40, plus 20 is 60, plus 8 plus 20 is 80, plus 100. So this is plus 20 all the way down, which means that the data is being taken every 20 minutes. But then if I look here she traveled 5 kilometers, but then check this out. In that next 20 minutes, she sped up. She traveled 15, and then she slowed down and she only went 5. Here she went none, took a break for 20 minutes, and then here 5. So this is where we can talk about the difference between constant rate of change versus average rate of change. Constant rate of change versus average. Constant would be adding by same number. Adding or subtracting. But if you notice, are you adding by the same number here? No, because here this is plus 5, but then it's plus 15. Then back to plus 5, then adding nothing at all, and then 5. So this one is not a constant rate of change. We are going to be looking for an average rate of change, which is the title of these notes. So most real-world data, you do not have a constant rate of change. Think of even the speed that you walk between your classes, right? Are you walking at a constant rate of change? Is every foot you take, every step you take the same distance? No. Sometimes like maybe up the stairs you're going a little slower, and then there's a big traffic jam in the middle of the intersection, and so you stop for a minute, and then you walk a little bit more, right? So your speed changes. That's what we have here. So we're going to find an average rate of change. To do that, we will use the first and last ordered pair. So we're going to use 0, 0, and 100, 30. I've defined my variables. I got my 2 points. Now let's calculate. M equals change in y divided by change in x. That's going to be 30 minus 0 divided by 100 minus 0. And if I stopped right there, let's see. Y is kilometers, and 100 is going to be minutes, because x is in the denominator and x is minutes. But I'm not really interested in how far she went in 100 minutes. I want to know how far she went in 1 minute. So to do that, I'm going to use my calculator. Get your calculator out and divide. 30 divided by 100 equals 0.3 kilometers per minute. So our interpretation of this is that on average, or let me put it this way, her average speed was 0.3 kilometers per minute. And that's it. That's done for number 3. Let's go look at one more for the notes, number 5, and I'm going to challenge you to press pause and work through the steps by yourself. So number 5 says, after 30 baseball games, A-Rod had 25 hits. After 100 games, he had 80 hits. What is his average hits per baseball game? And I'm going to verbally remind you of the steps. First, define your variables. Then, step 2, get your ordered pairs. Step 3, calculate the slope, change in y divided by change in x. And then last but not least, interpret your values. Another hint to define your variables, remember y per x. Press pause, and when you're ready, we'll compare answers. So right now, I'm assuming that you did press pause for about 3 minutes at a minimum, and you tried number 5. So let me go back through those steps, but now I'm going to write it down as I go. My first step is to define variables, and I know y per x, so x is number of baseball games, or number of games, and y is number of hits. Step 1 is done. Step 2 is go get yourself some ordered pairs. I need 2 of them. In 30 games, he had 25 hits. So that's going to be 30, 25. And then 100 games, he had let's see, 80 hits. All right, halfway there. I defined my variables. I got my ordered pairs. Now it's time to calculate the slope. M equals change in y divided by change in x. So let's see, that's going to be 80 minus 25 divided by 100 minus 30. 80 minus 25, calculator, is 55 divided by 70. If I stop right there, I technically could give this a real-world meaning. Y is all about hits, so that's 55 hits, and then 70 is an x value, x is games. But I'm not really interested in the statistics about how many hits per 70 games. I want to know how many hits per game. So to do that, let's divide. We're going to do 55 divided by 70, and we get 0.78. It says 0.7857. We're going to round to 3 decimal places, so 0.786 hits per game. And our sentence will be A-Rod averaged or averages 0.786 hits per game. So it's not what he does every game, because every game is different. So this is a great example of an average rate of change, again, not constant. No baseball player can go into the game knowing exactly that consistently he will hit this many games or this many hits per game. But from all of the data collected, they can calculate an average, which is what's happened with A-Rod in this question. So I'm going to stop it right there for today's notes. I know there's some more odds here. If you have some time to continue working on some of the odds, that would be great. Otherwise, I will see you in class tomorrow, where we will pick up with in-class practice for average rate of change. Have a great night, everybody.